title of my presentation is Potential for Hemp Production in Southeast Missouri. My name is Anthony Ohmes. I'm a field specialist in agronomy for University of Missouri Extension. 2018 Farm Bill, administered by USDA, and Missouri legislation, administered by Missouri Department of Ag Hemp Program, formed the framework for commercial production of industrial hemp in Missouri for 2020. More information on the regulatory components can be found on the respective websites. There are numerous online resources on the agronomic production of industrial hemp from various universities. University of Missouri has a hemp program website. University of Kentucky has been studying hemp production since the 2014 Farm Bill's pilot program and is a good resource. There are numerous potential uses from the hemp plant. For simplicity, I look at the potential uses to comprise of three parts of the plant. The most publicized and what many think of as industrial hemp is CBD, which comes from mainly the flower parts, in particular the hairs found predominantly on female and to a lesser extent male flowers. Other uses come from grain production for food and oil, the fiber, which is comprised of the outer vascular cambium called bast fiber, and the inner core called the hurd, which are used in various industries such as textile, construction, automotive, and agriculture. The fiber production component is what our agronomic focus will be today and what our initial 2020 trial was evaluating. Hemp is a summer annual, and flowering is triggered by day length. In general, hemp is considered a short day plant, with its reproductive stage beginning a few to several weeks after the beginning of summer, June 21st. Industrial hemp varieties, in general, have separate male and female plants. However, there are some plants with separate male and female flowers on the same plant. Male plants typically flower and senesce earlier than female plants. This is important in fiber production since harvest timing is based on male plant flowering. Pest management can be a challenge since there are limited registered pesticides for hemp. There are, in general, limited to biological organic products for disease and insects. Weed management needs to be built around fields with a history of low weed pressure, plant competition from uniform stands in narrow row spacings for fiber, or mechanical weed control in wider row spacings in other production systems. More information on registered active ingredients can be found on the EPA website. Research and more information will need to be gathered for what varieties might work best for fiber production in Missouri across its diverse climate and weather extremes. Research out of Kentucky has shown variability in germination ranging from 60 to 96%. Vigor is another component that needs further investigation, since seed size and hemp's ability to emerge under stressful environments, such as soil crusting, is variable. With seed size variability, concerns over vigor and emergence, planting depth for fiber hemp is recommended at 1/4 inch with good soil to seed contact. Maintaining soil moisture during germination at this depth will also be important. Drilling hemp seed for fiber at 7.5 inch row spacing is recommended to encourage internode elongation to increase height for yield, maintaining a small diameter stem for harvest, and providing competition for weed control. Seeding rate range is 40 to 60 pounds per acre. Seeds per acre as a potential standard, such as other crops, to account for seed size variability needs to be considered for future research. In general, May is a recommended planting month. However, planting date research is another area to help identify ideal timing for maximum fiber production. Planting too early can stagger or delay germination, which can increase the potential for seedling disease. Planting too late can reduce growth and overall yield. Hemp germination research at Virginia Tech evaluated 7 cultivars originating from Canada, Northern Europe, and Southern Europe. The data suggested an interaction between origin of seed and soil temperature. Germination percentages of 80% or greater range between 55 degrees Fahrenheit and 80 degrees Fahrenheit, with optimal soil temperatures for northern latitude cultivars between 60 and 68 degrees and up to 77 degrees for southern cultivars. Harvest can be with traditional forage baling equipment. Harvest timing is when 20% of male plants are flowering. To help with the separation of the bast fiber and the hurd, a field process of retting, where cut plants lay on 4 to 6 inch stubble for a few weeks is required prior to baling. There are some hurdles, some challenges, and some opportunities to growing this crop. What is needed is more research and finding ways to fund research to develop systems for Missouri, address concerns about pest management, especially weeds, development of uniform standards and procedures as we see in other row crops for quality control, working with a new and developing industry and identifying markets. This year, University of Missouri established plots with 4 varieties on several research stations across the state, including the Fisher Delta Research Center. The varieties evaluated were Genma, H51, Billa, and Helena. Delays, including weather, delayed the first planting date until June 8th. The second planting date was June 30th. Plots were drilled on 7.5-inch row spacing at a target depth of 1/4 inch at 50 pounds of seed per acre. The soil type is silt loam with a pH of 6 and very high phosphorus and potassium ratings according to soil tests. Rainfall occurred the day of and subsequent days following each planting date. What I learned this season is crusting is a challenge for these plants to push through. The first planting plots were rotary hoed, but did not seem to improve emergence in this study. However, this could be possibly due to timing, but also upon further evaluation could have been due to low germination in the field. However, a germination study was not conducted. The variety Genma did have the highest stand counts, although all stands were thin at the Delta Center location. This leads to another important pest management component. Open canopies reduce shading and increase weed emergence. It is important to take stand counts early, and if stands are thin, consider replanting. However, more work needs to be done on replant decisions and where populations should be to maintain yield potential and maximize competition. I did have an opportunity to visit some commercial production fields this summer. They were planted in early May, and they had uniform thick stands with minimum weed pressure. Things did look good. So in summary, hemp in Missouri is a promising alternative crop with potential to increase acres as the industry continues to find innovative ways to use this versatile crop. With any newly introduced commercial crop, there is a steep learning curve that will take some time. With that, there will still be some growing pains, which are not only challenges, but opportunities. If considering growing hemp, utilize resources to learn about this crop. Some agronomic considerations to think about include, for fiber production, planting early enough to maximize growth while not impeding or slowing germination, as well as planting depth. Avoiding poorly drained fields and fields with a history of heavy weed pressure, especially pigweed, should also be considered. It is important to have a plan, budget, and market outlet for your crop and know the regulatory requirements before planting. I want to thank the Fisher Delta Research Center and Grover Shannon, interim superintendent, for the land to plant. I want to thank Jim Heiser and Corey Cross for expending time and resources for planting and management of plots. I also want to thank Tiber Fiber for supplying the 4 varieties for us to evaluate and learn a little more about this crop. If you have questions, I can be reached by phone or email. Thank you.